The universe is unimaginably vast. There are hundreds of billions of stars in our galaxy alone, many of which are far older than our sun. It seems highly probable that someone out there must be looking back at us, and yet, no matter how closely we listen or observe, we've heard only silence. This puzzling contradiction is known as the Fermi Paradox. It poses a simple yet persistent question. If the cosmos is teeming with opportunities for life, then where is everyone? Consider this. In the grand 4.5 billion year history of the Earth, our civilization is relatively newborn. Meanwhile, the galaxy around us is ancient. If an extraterrestrial civilization had arisen even a few million years before us, a mere blink of cosmic timescales, it could have already spread across many stars. Physicist Enrico Fermi famously pondered this in 1950, asking over lunch, "Where is everybody?" A question that continues to echo in scientific circles. Decades later, we're still searching for an answer. Have advanced extraterrestrials ever existed? And if so, why haven't we encountered them? Over the years, scientists and thinkers have proposed numerous hypotheses to resolve the Fermi Paradox. Each offers a perspective on a possible cosmic truth, some hopeful, some grim. Let's explore some of the most fascinating scenarios, traveling through the ideas of danger, isolation, and rarity in search of reasons for the silence of the stars. Our first stop is a place of danger and silence, the dark forest. While this idea originates from science fiction author Liu Xinjin, it resonates as a chillingly plausible reality. Imagine the universe as a vast, ancient forest at night. Each civilization is like a hunter, armed, wary, and moving stealthily among the trees. They know that others might be out there, but revealing their presence by making noise could be deadly. According to the dark forest hypothesis, intelligent civilizations remain silent and hidden out of fear. Any form of life that announces itself risks drawing the attention of another, one that might see it as prey or a threat. In Liu's eerie analogy, the cosmos is filled with silent, paranoid beings, each stalking like a ghost in the darkness. No lights, no signals, only the hush of hunters trying not to be hunted. Why such fear? Because in this dark forest, survival is the only rule. Resources are limited, and any other civilization is an unknown, its intentions and capabilities unclear. Even the weakest seeming culture could suddenly leap ahead with new technology and become a mortal enemy. The safest strategy is to assume the worst. If you hear another in the forest, eliminate them before they eliminate you. So everyone stays quiet, erasing any traces of their existence. This hypothesis flips the Fermi Paradox on its head. Perhaps the great silence isn't because we're alone, but because the galaxy is full of life forms too terrified to announce their presence. If the dark forest is real, an unsettling thought arises. In searching for friendly extraterrestrials, the simple act of shouting, "We are here," could be the very thing that leads to our doom. However, maybe silence is not just out of fear. It could be the result of something even worse. Not hiding, but extinction. In the cold vacuum of space, another grim possibility lurks. What if we haven't heard from extraterrestrials because they're all gone, perhaps wiped out by an unstoppable threat? This is the Berserker Hypothesis, perhaps the darkest explanation of all. It suggests that civilizations across the galaxy aren't silent by choice, but forced into silence. The idea gets its name from fictional Berserker probes, deadly, self-replicating machines programmed to seek and destroy life. Imagine an automated killer, a robotic virus, spreading from star to star. Such probes, often referred to as von Neumann probes, after the mathematician who theorized self-replicating machines, could multiply exponentially and sweep across the galaxy. If even one advanced species were to unleash something like this out of paranoia or malice, it could mean the doom of all others. Astrophysicist David Brin once remarked, "It need only happen once for the results of this scenario to become the equilibrium conditions in the galaxy." In other words, a single outbreak of berserkers in the distant past could have left the galaxy silent and lifeless. According to this hypothesis, the Great Silence exists because whenever life becomes loud enough to become noticed, say by broadcasting radio signals or launching space missions, berserker probes detect it. Then, like cosmic predators, they descend and erase that life before it can spread. The universe in this grim scenario might be littered with the ruins of civilizations that reached for the stars only to be extinguished. If this is true, we are lucky, or perhaps only lucky for now, that we haven't yet attracted the attention of something predatory lurking out there. Brin once summarized this chilling idea with a warning. If the berserker scenario is correct, we will not find a single intelligent life form out there, including, one day, ourselves. This fear is valid. Our SETI signals, our television broadcasts leaking into space, could one day serve as a beacon leading to our own destruction. And yet, if we're still here, perhaps the worst hasn't happened. Or maybe something or someone is actively protecting emerging civilizations like ours. What if the silence is not enforced by killer machines, but by a form of cosmic caretaking? Let's consider another scenario, slightly less terrifying. What if advanced aliens are indeed aware of us, but prefer to remain hidden, much like zookeepers behind a one-way mirror? This idea is known by the playful name, the space zoo hypothesis. It suggests that we, humans, are essentially an exhibit, or an experiment, being observed by higher civilizations that have agreed not to interfere with our development. In other words, we haven't encountered aliens because we aren't supposed to. In this hypothesis, Earth is akin to a wildlife reserve, or a protected island tribe. Think of the uncontacted people of North Sentinel Island in the Bay of Bengal. They live in isolation while the modern world watches from a distance, respecting their wishes and legal protections that ensure that they're left alone. Similarly, advanced aliens might enforce a strict non-intervention policy toward developing civilizations like ours. This could be driven by ethical concerns, like the belief that young species should find their own path without external influence, or simply a form of cosmic anthropology, allowing them to observe us to understand how intelligent life evolves naturally. The zoo or space quarantine analogy implies that evidence of alien existence might surround us, but it is deliberately hidden. We scan the skies and see nothing because we're looking at a one-way mirror. They see us, but we don't see them. This is almost reassuring. Instead of a hostile jungle or an intergalactic slaughterhouse, the universe in this scenario is a vast wildlife park, managed by benevolent or at least indifferent overseers. But there's a catch. It implies the existence of some kind of galactic club with rules we don't know. And this raises another possibility. Perhaps this isn't just passive observation, but active enforcement of cosmic law. If the zoo hypothesis portrays aliens as discreet caretakers, the space police hypothesis depicts them as galactic enforcers. Imagine a highly advanced civilization, or a whole coalition, patrolling the stars and enforcing laws on any rebellious society. As soon as a civilization becomes spacefaring, or starts developing dangerous technologies, the space police arrive and lay down the law. Stay put. These are the rules of the galaxy. This idea is essentially an extension of the zoo concept, but with a more active role. Perhaps an unspoken prime directive exists in space, a term borrowed from Star Trek's non-interference doctrine, and a powerful civilization ensures its enforcement. They might prevent young species from making reckless moves, such as aggressively expanding, sending out self-replicating probes, or developing planet-destroying weapons. In a way, they could regulate behaviors that could threaten others or destabilize cosmic order. If humanity crosses a certain line, say by attempting to create an uncontrollable AI or launching a Van Neumann probe swarm, this hidden authority might intervene, and perhaps not with a friendly warning. Some theorists have joked that the police might simply send an asteroid our way as a harsh lesson. It's a risky test. If we push things too far and nothing happens, maybe there are no vigilant guardians after all. But if they do exist, crossing that line might be the last thing we ever do. So far, there's no evidence that anyone has intervened in our affairs. No alien officers handing out fines for humanity's bad behavior. But there's a certain dramatic appeal to this hypothesis. The idea of an organized galactic community that cares enough to prevent cosmic disasters. If true, perhaps we remain unharmed, not by chance, but by design, protected until we are mature enough to join the Galactic Club. But what if, unlike all these scenarios, the simplest answer to where is everybody is there's no one out there, or at least no one capable of saying hello? Perhaps life, especially intelligent life, is exceedingly rare. Earth often seems ordinary, a typical rocky planet orbiting a fairly unremarkable star. But what if Earth is actually the winner of a cosmic lottery? The rare Earth hypothesis argues exactly this, that the emergence of complex life here required such an improbable combination of conditions that it might be practically unique in the universe. In other words, intelligent civilizations might be rare and scattered, or even one of a kind, because the odds were stacked against their evolution. Consider everything that had to happen for us to exist. We are at the perfect distance from the sun, allowing liquid water to persist. Our sun is stable, neither too hot nor too cold. We have a giant guardian, Jupiter, whose gravity deflects comets that might otherwise frequently strike Earth. We have a large moon that stabilizes our planet's tilt and seasons. Plate tectonics regulate our climate, and we've been afforded the exact right amount of time for life to evolve from microbes to multicellular organisms. Even rare events, like ice ages and mass extinctions, might have triggered evolutionary leaps at the right moments. It's a long list of lucky coincidences that, when combined, could be extraordinarily rare. Paleontologist Peter Ward and astronomer Donald Brownlee, who popularized this hypothesis, noted that microbial life might be common. Microbes are hardy and can survive extreme conditions. But the transition to complex animal-like life may require a stroke of luck that happens only rarely. If advanced life needs a planet exactly like Earth, with all these special factors in place, it's no surprise that we don't see alien neighbors. We might literally be the only technological civilization for galaxies around. This scenario is sobering in its own way. The silence around us might not be due to fear, hostility, or regulations. It could simply be that no one else was lucky enough to make it this far. Earth could be a rare oasis in a sterile cosmos. If that's the case, then an immense responsibility falls upon us. In a sense, we carry the torch of consciousness for the entire galaxy. It's a call to cherish and protect the life we have, knowing how fleeting and improbable it may be. And yet even the rare Earth hypothesis doesn't close the case completely. After all, the universe is vast. Even rare events can happen multiple times with enough cosmic dice rolls. Perhaps intelligent life emerges elsewhere, only to encounter obstacles it cannot overcome. And this brings us to a profound concept that looms over any discussion of cosmic loneliness: the Great Filter. The Great Filter is not a single hypothesis, but rather an overarching idea. It suggests that on the path from simple life to an advanced spacefaring civilization, there is a stage that is extremely difficult to overcome, so difficult that almost no one makes it past. The filter might be behind us. Perhaps the leap from non-life to life is so rare that it's only happened once in our galaxy, and we have already passed that threshold. Or the filter might be ahead, an obstacle that nearly all civilizations reach but fail to surpass. If that's the case, we've yet to face the greatest challenge: Economics professor Robin Hanson, who coined the term, described the Great Filter as a probabilistic barrier, a series of highly improbable steps in evolution or development. For example, it may be extraordinarily unlikely for life to evolve from simple single-celled organisms to complex multicellular ones, or for intelligent animals to develop technological civilizations. If even one of these steps is astronomically improbable, it would eliminate the vast majority of life forms before they ever reach the stars. Philosopher Nick Bostrom put it succinctly: if we find the cosmos empty, it might mean almost no one can get all the way to detectable spacefaring status. Something stops them. A chilling implication. If we discover primitive life elsewhere, such as fossilized bacteria on Mars or microbes on Europa, it would suggest that the early stages of life are common. And this would mean the Great Filter is most likely ahead of us. A rare, fatal step may lie somewhere in the future, waiting to be faced. And we must ask, what could this future filter be? Nuclear war? An AI gone rogue? Environmental collapse? One candidate that scientists soberly consider is a pandemic, whether natural or engineered. We've already seen firsthand how quickly a new virus can spread across the world. Even with modern medicine, a pandemic can claim millions of lives and destabilize civilization. Now imagine a disease far more lethal, or a genetically engineered superpathogen. It's not surprising that an advanced society could, either by accident or intent, create something it cannot control. The renowned physicist Stephen Hawking warned that humanity's growing technological power leads to, quote, new ways things can go wrong. And he specifically feared engineered viruses as a potential civilization-ending threat. Could a virus or a plague be the great filter that naturally limits intelligent life? Possibly. A sufficiently deadly global pandemic, breaking out before a species can colonize other worlds, could wipe out civilizations or revert it to the Stone Age. Humanity bears the scars of past plagues like the Black Death in the 14th century, which wiped out a third of Europe. One can only imagine alien worlds where successive pandemics destroyed societies before they ever sent a radio signal to the stars. Interestingly, viruses have also been an integral part of evolution itself. Astrobiologists note that viruses are widespread on Earth and may have existed since the origin of life. They drive evolution by forcing organisms to adapt. In fact, some DNA in our own genome comes from ancient viruses. Without this pressure, complex life might never have arisen. In this way, viruses play a dual role. They can accelerate the progress of life, but they can also trigger catastrophic collapse. The idea that a great filter lies ahead is undeniably frightening, but it can also be seen as a call for wisdom. If pandemics, climate collapse, or warfare are potential filters, then our task is to overcome them, to prove that we can be one of the rare exceptions that make it through. Every year we survive and advance, carefully, collectively, is a year we move closer to proving that intelligent life can outlast its vulnerabilities. So what awaits us? We've wandered through the dark forest of paranoia, fled from hypothetical cosmic predators, peeked into an alien zoo, envisioned galactic patrols, pondered the uniqueness of our Earth, and faced the looming filters of fate. Each hypothesis paints a vastly different answer to Fermi's famous question. Perhaps the truth combines elements of several theories, or is something entirely unpredictable. For now, the great silence remains one of science's deepest mysteries. It's humbling, yet also inspiring, whether we are truly alone or just one of many hidden in the cosmic night. The search itself unites us. Every message we send to the stars, every exoplanet we scan for biosignatures, is an act of hope. It's our way of saying, we are here and we are listening. And one day, perhaps, we will hear a response, and on that day, the silence will end. And the next great story of civilization will begin.